Good morning, my name is Marco Zuppone. I'm a Dell KACE trainer based in Bracknell, UK, and today I'm going to talk to you about Wireshark. Wireshark is not a Dell KACE product, actually it's an open source product, but it's very important because it can help you to troubleshoot and analyze network issues. So what is Wireshark? Wireshark is a free open source packet analyzer created by Gerald Combs, and initially it was named Ethereal, but in the 2006 the name was changed in Wireshark for copyright reasons. Wireshark is a tool with functionality similar to TCP dump, but has the big advantage to have a very good GUI. Instead, TCP dump is only a text command. Mainly, there is no GUI at all, and and this GUI improves a lot the ability to troubleshoot the problem, because you can see graphically the packet, you can dig in the packet. It's much better to have a log of 1,000 lines, for example, and is very simple. It's not simple, but it's simpler to use TCP dump for sure. As TCP dump, Wireshark needs the libcap library to be able to capture the traffic. If you want only to analyze a dump, a network dump that captured with a TCP dump or Wireshark, you don't need to install this libcap library. On Windows it's called WinPcap. But if you want to capture the traffic on that machine, you will need to install this libpcap library. So what do you need and how you can get it? Wireshark is available for free on many platforms. You can find even the source code of it, because it's an open source, but you want normally to download the already pre-compiled binaries. You will find binaries file from Windows 2000. I bet they should be still around, to Windows 2008 R2. It works even on the most recent operative system. It is available for 32-bit and 64-bit OS. Is available for Mac OS from Snow Leopard 10.5, and is available pre-compiled for some Linux flavors, but you can, if you want, you can download the code and recompile by yourself. Maybe it's not so easy, but you can do that if you want. You can download it for free at wireshark.org, and there are many pre-compiled, as I told you, packages, and most of them, they include the libpcap library that if the installer will install if is needed. Why this tool can help me? So most of the application now depends strongly on the network communication to work and to work well, and so if something goes wrong in your network communication between the application, between the client and your server, you will face problems. So how you can spot the problem, what you can do to find out what is causing the problem exactly. You may think, okay, I can rely on logs, I can enable the debugging log. For example, for the case agent, you can enable a verbose debugging for the agent, and so you can rely on the log. If there is an error, for sure the log will tell me, okay, I was not able to connect here, I was not able to connect there, etc., etc. But logs are written from a program. So a developer wrote the procedure to log the problem. Can you trust that? Can you completely trust that what is written in the log is real? Maybe not all the time. Not everything is logged there. What you see in the logs may be a little bit sometimes not true. Sometimes you can spot fake errors. So you cannot always trust completely the log, but you can trust your network traffic, because the network traffic captured with Wireshark is really what you see on your wire, what the packets that are going to the server and they are returning back. So the packets never lie. Log can be misleading. or they don't capture the whole story, as we said before. For example, you can see in some logs, not only the case log, but I'm talking in general, error downloading the definition, but from where sometimes there might be the address is missing, at which address, what port it was using while it failed to download the definition. Wireshark can give you this kind of replies. And as I said before, the logs are written by developers and they are prone to errors as well. The logging system is prone to error as well. So how to install it and where? So to install Wireshark on Windows and macOS, you need to be triple N certified. So what it means, triple N certified, you need to be able to click on next, next, next. That's it. It's really, really easy. You don't need the incredibly technical skill to install Wireshark. Where you want to install it, you need to install Wireshark on the device that you want to use to capture, or on the device that you want to capture the traffic that is originating or receiving the traffic. Where you need to position your laptop or your device with Wireshark going to capture the traffic, this is another story. But mainly, if you want to analyze what is going on between a computer with the case agent on it, and you are able to install their Wireshark, it is a good idea to start your investigation from there. Sometimes can be tricky to choose where to start to capture the traffic. Normally, it is better to capture the traffic closer to where you think you have the problem. So if you suspect or you know that between your client and the server there are some devices that can mangle the network communication, like WebSense appliances, firewalls, you have something that is doing NAT, SNAT, you may want to start your investigation from the point that you think the failure is originating, and then maybe you want to capture the traffic on the other side of the appliance as well, to find out if the traffic is mangled in some way, or maybe is the router, is the firewall, is the appliance, the security appliance that is causing the issue. So you may want to compare the traffic before the appliance and after the appliance to find out what happened to it. So generally speaking, capture the traffic closer to the problem. This is the interface of Wireshark. The interface changed a little bit in the latest version. This is the latest one, and now we will see how to use it. It is very well organized. One very good thing about Wireshark is that Wireshark is available on different platforms, and then the interface is consistent between all the platforms. That's fantastic, because you can use it on Windows, then you can use it on macOS, and you can use on Unix. The interface will be mostly totally the same. Always you should keep an eye on the status bar. It always shows important information like expert information, what profile is used, and the packet field name. You will see that when you start to capture the traffic, and you can click on the packet and explode it, and click on the fields of the packet. In the status bar, you will always see what packet, what field you are on. So it will help you to understand what is the name of the field that is currently selected, plus other important information. Now let's have a look how to begin a capture, and you can do it in a lot of ways. There are equivalent, but there are different ways in Wireshark to start a capture. The most common ways are select the interface from the interface list and press start, or click, if you like more the keyboard combination shortcuts, Control E like England, and the capture begins immediately with the default option. Or another way is to click on the interface list. Another way is to click on one of the first icons in the ribbon. or use the capture menu. And when you start the capture, you can generally choose some option. The most important option you need to know in the capture option panel are promiscuous mode and enable network name resolution. Enable network name resolution need to be used with caution, because this will generate a load of DNS traffic request, because for every IP you want to do a reverse DNS lookup to find out what's the name of the host. So this can generate a lot of traffic towards your DNS, and then more traffic you have in your capture, more than you need to filter out to focus on your problem and not on the traffic that you don't really want. So what is the promiscuous mode? Is a good idea to have it on or off. So promiscuous mode. In promiscuous mode, your network interface is going to receive all the traffic, even if it's not directly is directed specifically to that interface. So, for example, if you have a device, let's say 10.14.8.1, that is trying to talk with another device with the IP 10.14.8.2 on the same network segment, in the promiscuous mode, you should be able to see the conversation, even if it's not for you. Maybe you are on a different device, but you are connected to the same subnet, and you are 10.14.8.10. You should be able to see the conversation between the 10.14.8.1 and the 10.14.8.2. You should. Why I said you should? Because there are many factors that may limit your visibility while you are in the promiscuous mode, like the switches. Now the hubs are gone. So I remember years ago, many years ago, there were a huge price difference between an hub and a switch. Now you cannot buy an hub anymore, mainly. So all the hub, even the $10 hubs are in with different kind of performance, are switches. So if they work well, you should not be able to see the traffic directed from devices that are connected from two different ports, because it should do a sort of channel within the two, so it's not broadcasting. You should not see that traffic, but there are ways to circumvent this issue. There are some solutions to this problem. One of these solutions on managed switches is to use a port and configure it like a span port. Another solution is to use an hub, if you find one. Maybe I don't know if you can still find an hub. For sure, it's difficult to find a 1 gigabyte hub. Another good idea, if your budget is permitting that, is to use a aggregating network tab. The aggregating network tab is a special kind of device that is totally transparent to your network, and you will be able to analyze the traffic in the middle. Even if you are not using promiscuous mode, you will be able to see all the traffic directed to you, for sure. Broadcast traffic, because broadcast is directed to everyone, and multicast traffic, even if you are not subscribed to that particular multicast traffic. The last thing may depend on the switch. Anyway, if you have a switch. In some specific circumstances, you may want to limit the traffic that you want to capture, and so you can use capture filter. Capture filter, they use a special grammar, a special syntax, and this special syntax is called BPF, Berkeley Packet Filter syntax. And it's totally different from the syntax for display filters that we will see later. Since version 1.6 of Wireshark, two very useful features were introduced, and the compile, one of them is the Compile BPF button, and this Compile BPF button, when you press it, it will give you an error if the syntax is not correct. Another nice feature is that while you type the syntax, you will see that if the color of the syntax is in red, it means that it's not valid, or if the color is green, it means that the syntax is valid. And then you can press always compile selected BPFs to find out if the rule is valid or not. But you need to be careful. First of all, use the capture filter. Use the capture filter only when you really need them, because remember that they are not display filters that make a selection of data that you already have. The capture filter will filter out everything that is not in the filter. So when you start the capture, the information that are going to be saved in your capture are the information, only the packets that match the filter. So everything that is not in that capture you cannot have it back. There are no ways to get the traffic back. For example, if you have a problem browsing internet, you may be tempted to use a filter such like IP port 80, so to take down the traffic directed to the from and to the IP port 80. But what about the HTTPS traffic? HTTPS traffic is not IP port 80, is 443. What about if the problem is a DNS issue? You will not find the client DNS requests and the DNS service replies at all. So you will not see anything about the HTTPS traffic because it's only port 80. So another thing you need to think about is that if a rule is a capture rule, is syntactically valid, so is in green, does not imply that the rule is logically meaningful. So there is a way to spot if the rule is not meaningful from version 1.6, but always you need to think logically to think, is the rule that I'm writing have sense or not. So let's have a look to the most common capture filters. Most common capture filters are, for example, IP, so we'll capture only the IP traffic, TCP only the TCP traffic, UDP only the UDP traffic. This other one, host and one IP address, will capture all the traffic from and to that IP address. This other one, not broadcast and not multicast, will not capture any broadcast traffic and any multicast traffic. These other about Ethernet with source and destination and host, so they will capture the traffic directly to that MAC address or from that MAC address, or all host is a bit a combination of SRC and DSC, so from and for that MAC address. Port 80 will capture all the traffic directed to port 80. We have not specified if TCP or UDP, so we'll capture all the traffic for TCP and UDP port 80. TCP and UDP is interesting because in your mind syntactically means all the TCP traffic and the UDP traffic, but logically is not good at all, because it means the packet need to be TCP and it need to be UDP as well. So you will not capture any traffic. A packet cannot be TCP and UDP in the same time. So if you want to record TCP and UDP, what you need to do here, you need to, instead of AND, you need to use OR. So or the packet is TCP kind, is a kind of TCP, or is UDP. If you will use AND, is a logical catch. You will not capture any kind of traffic. So to capture some traffic now, you set your interface. You click on your favorite interface. You set your options, and then you press start. So there is not a demo in this particular video, but in my example, only to let you know, I installed the Wireshark on Windows 7 64-bit with the case agent on it, and then from the case web console I forced the inventory. So I got the following result. You will see the next slide. The K1000 IP is 192.168.132.132, and the client IP is 192.168.132.50. So this is what I obtained, the first screenshot at least. So let's have a better look. So in the first four, from packet 4 to packet 9, we can spot a conversation between the client and the server. This is the AMP agent that periodically sends a TCP packet on port 52230 TCP to the server. This is called the heartbeat packet. So what is the heartbeat packet? Every case agent is installed. They are sending this packet every around 20 seconds. They are sending this packet to the K1000 server. Why this packet is really important for a couple of reasons. First of all, in your inventory you will see some you will see a sign near your device, so you can spot if the device is connected, to the K1000, so is able to reach the K1000 or not. In version 5.5, this icon was a red icon or a green icon. Green if this heartbeat packet is received by the K1000 server, red if this is not received from the K1000 server. And it's important that the heartbeat packet is received. Why? Not only for the status, but because, as we know, quite the 100% mainly of the conversation between client and server with case are between the client and the server. So it is the client that is calling the server with this heartbeat packet, and then the server can communicate, can tell to the client what to do using this packet mainly. So when the server, when the client calls in with the heartbeat packet, say, hey, I'm here, my address is blah blah blah, and so the K1000 will use this connection made from the client to the server to tell him, good to see you, now you need to do this, and that. So the communication is mainly monodirectional from the client to the server. So the initiator of the conversation is the client. The server will mainly never initiate a conversation with the client. So 99.9% of the conversation are from the client to the server. So if the heartbeat packet, you don't receive a heartbeat packet, okay, you need to find out why. On packets 10 and 11, the client is inquiring about what is the MAC address of the DNS server using the ARP protocol, address resolution protocol. Packet 12, the client is asking to the DNS to resolve the host k55.case.local that is my K1000 server. Packet 15, the DNS replies that the IP for k55.case.com is .local, is a typo in my slide, is 192.168.132.132. Beginning from packet 17, you can spot loads of HTTP traffic towards the K1000. Analyzing the payload of these packets will tell you what the client is telling to the server and what the server is telling to the client. But you will see loads of different packets. How we can do better? Well, can we see this conversation in a better way? We will see how to do later. So some ports have some symbolic name associated to them. The name are registered by the interested parties to the IANA. The file service under program files Wireshark folder contains the association between the number of the port and the symbolic name. And if you want, you can edit it. If you want to edit something, I always recommend don't use Notepad in Windows. Never use Notepad. In Unix, you can use VI. I recommend you in Windows to use Notepad++. So if you want to open, if you want to know what is the number of a port without opening the file, just click on the packet in the details section, and you are able to see the symbolic and numeric port, the symbolic name and the numeric port. So to determine where your configuration file are stored, you can go in the help menu about folders tab. It will tell you this works in every architecture, and actually this will tell you where all your configuration files are stored. So we said before, we saw that you in the previous capture you have a lot of conversation. After the initial packets, you have HTTP conversation, and you see loads of packets that represent your HTTP conversation. How you can see it better? So we have a very nice tool called nice feature of Wireshark is follow TCP stream and follow UDP stream. This is one of the most useful function on Wireshark, and you will use it a lot. You can see that in packet 16 there are some payload, and in some subsequent packet as well. It's not very handy to read all these things in this way. So what you can do, you can click on packet 16, right click on packet 16, and choose the option follow TCP stream. You will see something like that. That's much better, much better, right? So the conversation are colored with two different colors, one for the client and another for the server, so you can spot much better what they were talking about, mainly. And if you want, you can you have some option there to export this to a text file, or export only these packets in another capture file and work on them. You have various kind of options in this in this GUI. So the requests and replies are colored in red and blue, and this is very handy to analyze HTTP conversation, FTP conversation, SMTP, POP3, all the protocol where there is at least some clear text. The feature is, and even if the payload is not totally clear text like SMB, for example, because it is possible, and we will demonstrate how to save the conversation stream to a file. So display filters. It's time to introduce display filters. Their knowledge is essential to make a good analysis of the traffic, because they help you to display only the traffic, the interesting traffic for you. So they are able, and they are there to solve the famous needle in the haystack problem. The syntax is very different from, and much more flexible anyway, from the Berkeley filter packets, and they can be applied while you are capturing or after the capture. If you apply them while you are capturing, they will affect only what you see, but they are not capture filters, so everything will be captured. If you are not filtering anything, everything it will be captured. You are only watching at what the filter is only a display filter mainly, so the data is still in your capture file, will still be there in the capture file if you save it, but this is only what you want to see now. The syntax is used for columns definition and coloring rules as well. There are columns, as you saw, you have a column set. This column set, you can change it. You can change your column set. You can create custom column, change the order of the columns, and things like that. If you want to create a custom column, the display you can use the display filter syntax to tell what you want to see exactly in that column. A coloring rule, we will have a look to them. So mainly, as you saw when you start a capture, you have all the packets colored in a different ways. You can define through with the same syntax of a display filter what kind of colors you want to assign to different protocols or packets that match a packet that matches a particular rule. So Wireshark come already with a predefined list of filters. You can use them like an example. That is always a very good idea to use these predefined filters like an example and find out how they were made, so you can make a copy of them and modify them a little bit. Display filters and capture filter are case sensitive. HTTP uppercase is not the same of HTTP lowercase. So fortunately, while you type the display filters, you can use the IntelliSense. There is a sort of auto-completion of what you are typing. So this helps you a lot. So to create a display filter, you can simply type in the filter field and get the advantage of the IntelliSense. Another way to create a filter is to explode a packet in the detail section. Click on a particular section and then right-click and choose prepare filter or apply filter. What's the difference between prepare filter and apply filter? The difference between them is that prepare filter will only prepare the filter and write the filter for you, but you will need to press the apply button to apply it. Apply filter will write down the filter expression for you and then will apply it directly. Another way is to press the expression filter that is near the filter field. A GUI will help you to formulate the expression, and this can be handy, but my favorite way is to write them directly and take advantage of the IntelliSense or the other method to right-click to right-click on a particular field of a packet, and then from there start to build my filter. So display filters, still what you can do if you want to filter a certain field but you don't know its name. The simplest way is always to explode the packet, look for the field that you want, click there, and then you can or right click and build your filter, or look on the status bar. The status bar will let you know what is the real name of that field. For example, here we clicked on the IP flag df. It's 1 byte long, and so if you want to make a filter about that, you can write ip.flag. etc. etc. That is the do not fragment field. It can be is a bit value, is a so is 1 byte, and normally it can be only 1 or 0. So 1 is the do not fragment is on, and 0 is off. So the general structure of a display filter is a sequence of expression. Eventually you can concatenate the expression with logical operators. An expression normally is a field plus a comparison operator plus a value like tcp.dst port equal 80. So the destination port of the TCP destination port is equal to 80. The most common comparison operators are double equal, pipe pipe, that means or, double ampersand means and, major equal than, minor than, etc., etc. But if you are really a nostalgic geek, you can use the literals like AQ or and GE is greater than equal, NE not equal, LE less or equal, greater than, GT, etc., etc. They are totally the same. So these are logical operators, double and double OR. And so this is an example. TCP.port. Port, what is the difference between a DST port, SRC port, a port? DST port is the destination port, SRC port is the source port. Port can be destination or can be destination or target. So it can be destination or source. So this is an example. TCP.port equal 80 or so TCP.port equal 80 or TCP port equal 443. So this will capture all the traffic to and for port 80 and to and for port TCP 443. Okay, another example is this one. If a filter is syntactically like the capture filter, if a filter is syntactically valid, does not mean that it is logically valid. For example, this is a common example, TCP and ARP. So the filter is valid, but I will pay you really a pizza if you are able to find in IP version 4 a packet that is in the same time a TCP packet and an ARP packet. So some popular protocols define basic filters that help you to mainly some kind of shorter name that speed up you to write a filter. For example, for popular protocol like DNS, the real filter should be TCP port equal 53 or UDP port equal 53. We always to remember DNS use mostly TCP, but they can use mostly UDP, but can use even TCP as well, especially for zone transfers. Okay, instead of write all of that, you can simply write down DNS. DNS means that. So this is another one, for example, TCP.port equal 80 or port 443. You can simply write a down HTTP. So there are loads of other popular protocols there, like ARP, BOOTP, SMTP, POP3, SMB, FTP, FTP data, LDAP, etc., etc. NTP as well. So in some special circumstances, we need to match one or more bytes of a packet in a specific position. That's a bit rare, but it may be useful to know that you have this ability. This kind of filter is called offset filter, and it is in the form field or protocol layer offset 0 based and the length and the comparison value. Let's see an example. So Ethernet dot SRC. SRC is the source of the Ethernet field. Between 4 and 2 need to be equal that value in hexadecimal. Or this is another example, the IP protocol between the offset 14 we take 2 bytes need to be equal 90 20. So the first one, Ethernet protocol, the source field of the Ethernet protocol, the offset from 0, so the fifth byte, we take 2 bytes and they need to be equal to 221F. In the other one, IP protocol stack, the 15th byte, we take 2 of them and they need to be equal to hexadecimal 9020. To formulate this kind of filters, you need to know the protocol very well, and you need to know what you are doing, mainly, what you are doing, what you are looking for. Coloring rules. So now we introduce a little bit of filter syntax. You can introduce coloring rules and columns. They are defined with the same syntax used for display filters. So you for sure you have noticed in our first capture that is very colorful. So how we do that? The coloring rules are very important because they help you to spot what is going on in a trace or when you are doing a trace. So you are able to see different colors, and because they match different coloring rules, and they really help you to find the famous needle in the haystack. So you can manage them through view, the menu view and coloring rules menu, and this is what you see mainly. The coloring rules, they color a packet if the rule expressed by the display filter associated to that color is matched. So the coloring rules can be created new. You can create new rules, you can delete rules, you can move the rules up and down, and this is very important because they are evaluated from the top to the bottom, so they are evaluated in order, so you can move them up and down. They can be imported, exported, they can be reset to the default, or it's not written in the slide, but you can simply disable them. So you don't want to delete the rule, but you want to temporarily disable the rule. You can do that as well. The coloring rules are saved in a file called color filters. The rule, as I said before, they have a precedence. So the rules are evaluated from the top to the bottom of the list. When a rule is matched, the evaluation finishes for that packet. So the packet will never have two different colors in the same time. So we evaluate from the top to the bottom. We find the rules matching the packets, and then we stop the evaluation. Now let's disable a very annoying rule, checksum errors. So most of the time this checksum error is a false positive error caused by the TCP UDP offloading settings of your network adapter. So it's a good idea to disable it. Don't delete it, it may be useful. You can simply disable it. Disable a rule is very simple. You select it, and then you click on the disable button. A line will appear on the rule and means that the rule is disabled. It is always better to disable rules instead of delete them, because you may want to re-enable them. Columns. Columns are fundamental to view the traffic that you captured. So the columns set, the standard column set is not always the best column set for the problems that you are going to analyze. It is possible to define custom columns, resize them, rearrange them as you like. Clicking on a column, you can sort the data in ascending and descending order. This feature is really useful, especially when you capture the traffic and then you select a second signs previous capture displayed packets, so you can find out the progression of the timeline of the packet capture. Custom column definition need the field name that you want to display, and it's the same field name you are using in the display filter syntax. So let's see how we create a new column. So there are many ways to create a custom column. So one of them is to go to Edit, Preferences, Column section, right click on a column and select Column Preferences. You right click on a field. This is another way. You can right click on a field and choose the option Apply as Column. In this case, the column definition is applied immediately, and the column and the column set and will be applied immediately in the column set. But if it's not what you want, you can remove that column using the column preference menu. Column definition, the column definition is saved in your current profile directory in the preferences file, and the active what profile you have is displayed always in the right down corner of the Wireshark window in the status bar. You can create different profiles, and you can switch between one profile to the other. So mainly profiles are a set of options, a set of display filter, collection of capture filter, column set, and other things. So you may want to in the future to create different profiles, and it's very easy. You will see you can create different profiles and then use one profile when you are analyzing web traffic, another profile when you are analyzing DNS issues, another one where you are analyzing other things. So you have different columns and different coloring rules, etc., etc. So let's try to create a new custom column. You need to click on Edit, Preference, Column, click to the Add button, select custom from the field type drop down. There are already loads of other columns predefined that you can use, but if you want something that is not there, something custom, you need to select custom, and then you can enter the field name that you want to display in the column, in the field name field, and click on the title of the column. You can name it as you want, and then you can press apply and then OK. So in this case we are adding a column that it will display the field DNS time. So there are some useful columns that you can add. For example, this depends on the traffic that you are going to analyze. You may want to create different configuration profiles, as I said before, and then you can switch between one to the other depending on the traffic that you want to analyze, on the analysis that you want to perform on that traffic. You can reposition them, delete them, hide them, and change the definition of them. Some useful columns that can be, for example, tcp.stream and tcp.windowSizeValue. So the first is useful to distinguish between from a TCP stream to another TCP stream, and the other one, window size 0. It will help you to spot the window size 0 condition. So when the window size value is going to 0 or is very low, it means there's some congestion problem in your network. So thank you for following this presentation. This is the end of the presentation. This presentation was a short introduction to Wireshark, but Wireshark can do much more than this. This was only a brief introduction to the most important and interesting functionalities. If you go to the wireshark.org site, you can find a lot of different link to site dedicated to this. You can even buy a book, a very good book about Wireshark. It is written by Laura Chappell, and it is even useful if you want to prepare for the Wireshark certification. Actually, there is a Wireshark certification called a VCNA, Wireshark Certified Network Analysis, and so you can you can do the certification or simply buy the book. It will contain loads of useful tips how to use it in a professional way in different to analyze different kind of network traffic. Thank you, and